We're going to prove the following fact, that the integral of secant raised to the nth power of x dx is equal to, and this one I need to copy down, this is equal to the tangent of x times secant raised to the n minus 2 of x all over n minus 1 minus n minus 2 over n minus 1 times the integral of secant raised to the n minus 2 of x dx. Notice the reduction in the power of this integral. It went from n to n minus 2. Okay, proof. Like most of these reduction formulas, this one's going to be done by parts. We are going to break off two secant x's. And we will have secant n minus 2 of x times the secant squared x's, the ones that we broke off, dx. And since we're doing this by parts, we call one part u and the rest dv. And please don't think it was you get to outright. It doesn't matter which you pick. It does. This has to be u and that has to be dv for what I'm about to do to work. So we let u equal secant n minus 2 of x, and dv is what's left over. And I'll jump on this one. I know that the derivative of tangent of x is secant squared x. And over here, du is, well, here secant x. I bring down the power. I make the new power 1 less. And then I multiply by the derivative of that. Derivative of secant x is secant x tan x dx. And then I'll note one thing, that those spaces are the same and I'm multiplying, so I can add the exponents. That's a 1 times tangent x dx. And I am going to call this integral that we're reducing I. So I is equal to u times v, secant n minus 2x u times v minus v times du. Well, that's du and that's v. So minus, I'll say the du first. It's n minus the integral of du du times v, which is another tangent x. That tangent squared x. And I'll make one change. I'm going to factor out the n minus 2 in front of the integral. N minus 2 times the n2. Okay. So what I want to do is rewrite that. I know it's going to have a 1 in it. And when I multiply this by the 1 times dx, I'll have the secant of a lower power of x dx. Lower than what I started with, which was n. So this is equal to secant of n minus 2 of x times the tangent of x minus n minus 2 times the integral of secant to the n minus 2 of x times another way of writing tangent squared x. And that other way of writing it is secant squared x minus 1. So, we'll distribute in a moment. So we get this minus n minus 2, and when I multiply those out, magic happens. I get back secant raised to the nth power of x dx minus, look how beautiful, I get a lower power now. Get the same form, secant over power of x dx, but the power was reduced. Okay, I'm going to distribute the n minus 2, and then we'll finish up the proof. I hope you see what's going on. I distribute the n minus 2. I get back secant n of x dx. Minus minus becomes plus n minus 2 times this integral times dx. Okay, let's get it in there. Okay, now this here is just I. That's just I. So on the left side I have I, or one I. When I bring these i's over, it'll become plus n minus 2i, and 1 plus n minus 2 is n minus 1i's. So if I bring this to the other side, I'm gonna get n minus 1i's. N minus 1 times I is equal to all of this except this piece. I brought it to the other side. This is secant n minus 2 of x times the tangent of x plus this piece. N minus 2 times the integral secant n minus 2x dx. And now I want I. So I divide the other side by n minus 2. So when I divide this side by n minus 2, n minus 1, I'll get I. I want to solve for I. N minus 2 integral of a lower power, and then I divide by n minus 1. So n can't be 1. But here, n cannot be 1. That is, n is equal to 2 or bigger. Now, if n was 1, you just have the integral of secant of x is raised into the first power you don't have to deal with. And we're supposed to know the integral of secant of x. Okay, so sorry about that. So this completes this video.